All right, last two things we have to talk about. We got to talk about Mars's moons. So Mars is the first inner planet other than the Earth that we've talked about, and the only other planet, inner planet, besides the Earth that actually has moons. So Mars has two moons, Phobos and Deimos. And basically they're captured moons. They look like just asteroids that have been captured by Mars's gravity. And the way their orbit is around the planet, eventually they will both fall and actually hit Mars eventually. So Phobos is closer, it's also bigger, and Deimos is smaller. But both of these, no more, they're 10 miles across at most, is how big they are. So they're very, very small. So this one is Phobos here, and then this one is Deimos. Phobos has an interesting feature to it, though. It's got a very, very large crater on it. It's called the Stickney crater. You're going to need to know that for your test. That's Stickney, Stickney. And the reason for that, I'll show it to you in just a second. There's Phobos and there's Deimos. You can see their distances away from Mars. So Phobos is closer, Deimos is further away. So this is the Stickney crater. So what happened was it was hit, this moon was hit, and when it got hit, it pretty much probably shattered the inside of the moon. And so when we go to Mars, we could actually build a little base on Phobos, and there's probably lots of caverns and stuff that would be a good shelter during the sandstorms that are on Mars. Mars has really, really big sandstorms. But Phobos, that's what it looks like, and that's Deimos. Phobos looks more heavily cratered. Deimos looks a little smoother. So that crater there, that is the Stickney crater. Stickney, Stickney. So those are the two moons of Mars, Phobos and Deimos. Last thing we're going to talk about is the probes that have actually been to Mars. There have been several landers and satellites that have gone to Mars. The first ones we're going to talk about. So Mariner 4 Mariner 4 went and did a flyby of Mars and took some pictures of it. That's where we got the face on Mars. And then later on, we had the Viking landers. So the Viking landers, there was Viking 1 and Viking 2. And they were landers. They actually landed on the surface of Mars. They didn't have any rovers or anything. They were able to insert a probe into the surface of Mars, get some readings, take some atmospheric readings, and they had video cameras. So this was the first photo from Viking lander, Viking 1 in 1976. And that's just a computer generated image of what it would look like landing. There's Viking 1 and that's Viking 2. And this is an actual picture of the surface of Mars from the Vikings. So you can see that the atmosphere, it doesn't, you can't just see space. I mean, it does have an atmosphere, and it's a very brown atmosphere. But it looks like it could be someplace on the Earth. You can also see a bunch of red rocks. So that is what Mars's surface looks like with the Vikings. Here you can see a bunch of white stuff on the ground. So that white stuff is frozen carbon dioxide. So I told you already that most of the atmosphere is carbon dioxide, and at nighttime the temperature drops. Temperature-wise, Mars, it does get it can get above freezing, but not very much. The average temperature on Mars is 210 Kelvin. So it is quite cold on Mars. But what happens is when the sun goes down at nighttime, the carbon dioxide freezes, comes down to the surface, and that's basically dry ice. And then when the sun goes up, it goes back up into the atmosphere. So another mission is called the Pathfinder mission. So during the Pathfinder mission, we sent our first rover. The rover was called the Sojourner rover. And the reason it was named Sojourner, it was actually named after Sojourner Truth, who was she worked for women's rights, and they named it after her. So this is the lander, and then I'll show you the Sojourner rover. It's this tiny little dune buggy looking thing, not dune buggy, but a little rover. It's pretty small. I'll show you a comparison of the Sojourner rover compared to the Spirit and Opportunity and the Curiosity rovers in just a little bit. So this thing, there wasn't very much equipment on it. It had a little camera on it. It could take a couple readings, but there wasn't really that much that it could do. It was just to see if we could get a rover there and then take some measurements. It wasn't really until 2004 when we got the Spirit and Opportunity to Mars, where we started taking some good measurements with how much water there is and what exactly the rocks look like and if they're sedimentary or volcanic. So that's just the Sojourner rover with the Viking missions. This shows you a comparison of the wheels of the three rovers that have been on Mars. So you have, this is the Sojourner, this is the Spirit and Opportunity rovers, and this is the Curiosity. So the Curiosity is about the size of a car. Spirit and Opportunity are about the size of one of my science tables, if you remember how big those tables are. And this one is like a little remote control car. There's a comparison of these are replicas of the Curiosity, Spirit and Opportunity, and the Sojourner probes. So this is the newest one. This one is still roving on Mars. The Spirit and Opportunity were both sent in 2004. The Spirit quit working in 2010, and then the Opportunity quit working in 2018. So this shows you how big the Curiosity is compared to people. So it's got lots of scientific equipment on it. It's pretty heavy duty. There's a new rover as well that's going to be sent very soon. I don't remember the name of it. They were last I saw they were having a contest to see what the name would actually be, and they've narrowed it down. I just haven't actually looked to see what it is yet, so I got to do that. This is a very famous Martian rock that came down and hit the Earth a long time ago, and we found it. When we found it, they analyzed the rock and they realized that this is probably a Martian rock. And when they saw what was inside of it, it was kind of a really big deal. There was a bunch of newscasts. The President of the United States, Bill Clinton at the time, he talked about what was in this rock. So when you look at this rock under a microscope, they found that there is fossilized microbes. So right here, you can see all these little pieces of fossilized what could have come from fossilized life, and that based upon the composition of the rock, they think it was from Mars. So that's one of the reasons why there's good possibilities of life actually being on Mars, besides the life that we've sent up with our rovers. So this was found in 1996, and we think it hit the Earth about 13,000 years ago. Okay, so this just shows you the sandstorm on Mars. It's got huge sandstorms that can last for months, actually. About a month, a couple days, a month, but they're very, very large sandstorms. This is just, I like this image. This is just shows you a sunset. So you have several pictures that were put together to make a panorama of the surface of Mars at sunset. And we're pretty much finishing up here. This just shows you a comparison of the atmospheres of all four inner planets. So Mercury does not have really an atmosphere. We said it has an exosphere, if you recall. Venus, we said, has the thickest atmosphere. Sulfuric acid clouds, very, very thick atmosphere, carbon dioxide, lots of pressure. Then here's the Earth with the atmosphere that we know and love. We have water clouds, ice, and then Mars has frozen ice clouds and frozen carbon dioxide clouds. Very little atmosphere. Most of it's carbon dioxide and nitrogen. For the Earth, most of ours is nitrogen and oxygen. And then for Venus, we said is carbon dioxide and nitrogen as well. We said Venus is the hottest planet. Mercury has the greatest change going from daytime to nighttime. And then we said Mars, it has an average temperature of 210 Kelvin. It can get a little bit above freezing, but most of the time it is below freezing. And this is just kind of what we just talked about with the components and clouds of the atmosphere. Make sure you know these for your tests, what the atmospheres are made of, whether or not they have clouds in the atmosphere, surface features of all these planets. Make sure you know your chart that we've been filling in. That's going to be a huge help for your test. And guys, that is it. We have finished the Inner Planets unit. This just shows you the size comparison and what the layers of each planet look like. So we've already said this. We started this unit by saying the terrestrial planets are called terrestrial because they're all made of rock and they all have interiors that are like the Earth. So they all have crust, mantles, and then cores.